Hello everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire, and today we've got Ali Salum, who has just completed the course C++ Basics for Robotics, and he'll be giving us a presentation on that. So what I'm gonna do is hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready.
Hello, I'm Salum, and I'm going to present my project, which I've just completed the last couple of days. And I'm going to present it to my colleague here, Mr. Desire, and hopefully it goes well.
Alright.
Yeah, so I will begin with the, we had to create two classes, not really create, but rather update and complete the needs to how the assignments were met. And there were two classes. The first one was no class, which is basically the procedural way of solving solutions. And the other ones was object-oriented, which has to follow the OOP principles, well, at least the basics of it. So I'm gonna, the non-class, which is just procedural, I'm gonna show you how I made a function which basically shows demonstrate all the functions you were supposed to implement. So I'm going to demonstrate that using the real robot here. So I need to first also compile and run the project itself. Where is it? Vectors. So for the non-class is just basically some basic movements with no clear, so as to say, some kind of a knowledgeable of some sort. It's just some clear basic movements, as you will see soon.
Okay.
Yeah, and as you're seeing here now on the logs, the first movement is just moving forward. It should be turning right now, and moving forward again, but then, so it doesn't really take notes of the obstacles that it's running into, but it's just really clear movements. There's a segmentation fault here, but yeah, that's supposed to be it, not exactly some clever robot as it's supposed to be. I'll reset it to a nice.
Alright, so as it stands, it just moves until it crashes, or does it try to stop?
No, it stops, but okay. I think we ran into some segmentation fault here for some reason. I'm not sure why. Yeah. I'm going to then show you how I implemented this non-class and those basic movements here. And the first one is the stop robot, which basically just sets the linear velocity and the angular velocity to 0 so that it can stop.
Okay.
And then we have the move robot front, which just moves the robot front as the function says, and it takes the argument speed, which we set when calling it, and it first checks if this speed itself is less than 0 or equal to 0. If it's equal to 0 or less than 0, then it doesn't move, so we just stop it, which we do it here. We'll call this function, which it did here, and then we set this the angular velocity, because we're not moving into any direction, so we just set it to 0, and well, the linear velocity, which is horizontal, we set the speed, which we did here. And
Okay.
then
All right.
the robot back, which is similar to the front, we just do the same thing, but then we set the speed to negative because then we are supposed to be going backwards. So hence the speed needs to be negative.
Okay.
So when we first call the method, we just put the positive linear velocity, but inside the function itself, we negate it so that it moves backwards and not in front.
Okay. All right. All
And
right.
then goes the turn left, which we basically follows the same principle, but we change angular velocity instead to the speed we just input here. Same goes with the right one, but then we're doing a right turn, so we expect a negative angular velocity. And then we go to the time moves front, which basically moves the robot in front, but at a speed and time. And we call the previous implemented function here, and we just turn the, not exactly turn, but convert the speed into milliseconds so that, because we are calling this sleep ms here, which basically expects milliseconds instead of seconds, so we have to convert the seconds that we provide here to milliseconds.
Okay.
So the move back, time move back is basically the same as move front, and the other previous mentioned functions like time left, which is basically the same, but just we are timing it. So yeah, and then we have the distance ones where we actually also provide the distance that we are expecting the robot to move, for example. And yeah, we first check if the distance is less than or equal to 0, or the speed is less than or equal to 0. So if that's the case, then we just stop the robot, because then there is no point of doing anything else, and then we just stop the function.
Can you tell me? Can you tell me why you
yeah.
have to do a casting there on line 137? Can you explain to me what you're doing there and why is it needed?
Yeah, so we're doing casting again because first one of the things is we're going to be calling the sleep here function, which if we're going to scroll down later, we're going to see that the sleep actually expect the milliseconds. But then when we are converting, we're getting this time here, we calculate the distance over speed. That's the formula for getting the time. But we are getting, these are doubles here. So to since time sleep ms expects milliseconds, which is an integer, so we have to cast this into an integer first, and then multiply it by 1,000 so that we can convert it to milliseconds, and then give it to the function sleep ms.
All right.
Then we go to the turn angle left, which is basically just providing the angle and angle speed and the angle that we are trying to make, which is pretty basic as well, similar to the previous one. So I won't waste your time on this one. Turn angle right, which is also the same. And then we have this function which, sorry, you had a question?
Let's see where you're calling all of these functions, right? So I want to see your main function. Let's just run through that one, because we want to switch to the class version and then test that as well. So
yeah, so we have this test all functions, which basically calls all the functions that we implemented. Here is the get.
I mean, so this is your test
I
script.
did not show
Your
you this.
These are your test functions, right? I want to see the
Yeah.
your int main function, right? Where you're calling all
Okay,
this.
okay.
Yes. So
Yeah, so this one calls all the functions, but then when we scroll to main, we just call it here, and then
oh,
the
okay, I see.
the way it tests all the function that we implemented.
Okay, I see what you mean. Okay, scroll
So
down one
should
more.
I rather show you? Sorry?
Scroll down a bit more. I want to see towards the end what is being done there.
Uh-huh. Uh-huh. I didn't do much here. I just called that the test function in the try catch.
Okay. All right. So what I want you to do is after we've done this, I want you to try and find out what is the source of the segmentation fault, right? So just do some digging on your own. But
Yeah.
anyways, let's switch to the class version and run that one and see how that one works.
Okay. So should I first explain the class itself, or should I first run it?
Run it first.
Okay, great. Let me get the commands here. Okay. Should I try to reconnect this?
Let's wait for it. I think this is just a stream glitch, so you should be able to see soon. So we'll run when we now have a full stream.
Yeah. There it goes.
Yeah.
Okay, so first run this visualizer here, and then run the oh, there it goes.
Click reconnect on a visualizer. Yeah, thanks.
Oh wait, this is actually the
You're running the
yeah, the non-class one. Sorry.
okay.
This. Yeah. Let's set it right to its own. Okay. Well, there it goes.
It is saying the decision has been made to turn right, but it's turning left. What's going on there?
Yeah, trying to understand it too. Okay. Let's set it.
Maybe get it out of the corner and let's have it at the starting point, so where the pedestrian crossing is, and then we can see if it manages to do it correctly from there.
I'm also trying to avoid the string on the block. Last time I tried to test. Where is it then? Last time I tried to test the robot. I think the robot is a little bit misbehaving somehow. Because I'm pressing the...
Okay, do something for me. Can you just do roast2 topic echo in the terminal?
Sorry?
Maybe, I think there are values that are latched, so... Okay, did it stop now?
Yeah.
Okay, so
I'm trying to keep it.
try running it from there, so don't change anything.
Before I run it, can just try to see what is happening here, because I'm trying to move it front and it's turning left. Did you see that?
Yeah, I did.
So that could also explain why the.
Okay, so maybe we have one move that's stuck. All right, no worries. So let's walk through the code itself, right? And we see how that one works. So enlarge your IDE screen so that it becomes a bit more visible.
Okay. Is that good enough?
Yeah, that's good enough. Yeah.
Okay. So we also implemented the same functions here too, but on this one again, it is implemented based on the OOP principle, basic principle. So we actually we created a class called robot control, and we implement the functions and everything else as members of that particular class.
Okay.
So then when we want to use this function, we just call an instance of this class, and then we just call the members and use them rather than trying to remember each particular class, function for each thing that you want. So we basically group them together in order to use them because they are basically doing similar stuff. So I'm not going to go through the previous function that we already went through on non-class.
No
just
worries.
going to scroll to something that we haven't gone through yet. Should I go through the odometry function as well, or
let's skip that one for now.
Okay. All right. Okay. So the first function that is unique to this class was obstacle prediction. The obstacle prediction is not by any chance perfect, but it worked well, and it takes an argument of threshold, which basically is the distance that we are trying to take before the robot hits to predict before the robot hits an object or an obstacle.
Okay.
So we first make a check if the scan ranges that we are trying to check on, if it's empty or not. If it's empty, as we are doing here right now, then we just run the function and there's no need to actually continue. Then we also have we get the front 90 degrees, which are like the front 90 from the right side and from the left side. So then we can get a clear view of what is in front of us, in the sense that we are predicting what is in front of us and not what is back. At least that's what assignment was saying.
Yes. Yeah.
Yeah, and we also have a check here which basically checks the indices of the vector of the scan ranges, if they are out of bound or if they're in the bound. So we check if the right one is in bound as well as the left one. If they are not, then we just also return. So because then we are not we shouldn't scan anything that's not bounded there. And then we also get the right index and the left index, the minimums and the maximums, so that we can know where to start and where to end, because we're going to look through these.
And what are your minimums and your maximums? So let's take, for example, the left. What is your min index and what is the max index? Like on on the circle itself, right? On what angle does your first your mean index starts and the max index end?
So on the left, it will be from 0 to 90 degrees on the left, and then on the right will be from 0 to 90 degrees on the right. So it's like you're on 180 plane, and
Okay.
and it's a half a circle basically.
Okay, so you chose to use two sectors instead. Okay.
Yeah, exactly.
Okay, let's go.
Yeah, then we look through the whole half a circle as I mentioned, and see if and have a check if there are any init value or is none value, which basically we don't want to check on these values, so we just skip this. As you can see, we are continuing here. And if they are not these values, then we just push this to the front ranges that we created here as a vector, and we continue to analyze those values there. And after the loop, and we found that there is nothing on the ranges. Then we just conclude that there's nothing here to analyze, and we finish the function.
Okay, so this function is just doing checking for obstacles, right? But which function is responsible for making your robot react to those obstacles?
Okay, I will go down and show you then, because there's also the direction tracking here, and then there's the naive obstacle avoider.
And are you using? All right. Are you using the logic from that previous function in this one, or you are re-implementing?
Yeah.
Okay, that's good.
No, I'm using that. Yeah.
All right. So run us through this.
Yeah. Because all those the function I was trying to explain were also in the assignment, so I had to also implement them in a way. Okay, so then there's the naive obstacle avoider, which we were trying to observe here, but
you're taking so many parameters there. Is that the ideal way of doing it?
I guess not, because then we could also as well just
because
include.
If I look at them, right, most of them are hard-coded, so you already have default values for these.
These are default values.
Yeah, so I don't see the reason why you had to put them have them as parameters, but maybe for your implementation you wanted to tune everything, but then they should be somewhere else, I guess.
Yeah, there is. There is when you're calling it, you can also input the values that you are needed for test or whatever, because I had to do a lot of tests to make it perfect, but of course it isn't perfect. But yeah, as I will show you when we call it here.
Yeah, just wait for it to.
Yeah, so when we call it here, we just input our own values, because then we are overriding the default ones which we put before.
I see.
Yeah, but then there's the ultimate function, which also basically call this, and the other function that we implemented. That was this, which I can also show you.
All right. We are out of time, but thank you very much, Ali. So what we're gonna do is let's conclude here, and then we will finish our conversation.
Thanks.
All right, everyone. So this was Ali's presentation, and a warm congratulations to him for getting the courage to come and showcase his work. Would like to encourage all those of you who would want to try this course or any other one that we offer certification on to do so, and